Now we're going to move on to a new topic, L'Hopital's rule. So I'm just going to bombard you with lots of examples, and then after a while we would take it step by step and try and understand why it works. But for the time being, I'm just going to bombard you with lots of examples. So if I were to ask you what is the limit of this, if you simply put zero into here, then you're gonna get zero, and then put zero into here. Sine of zero will be zero. Put zero into here, you're going to get 0 over 0, and this here is an indeterminate form. So whenever you come across a 0 over 0 scenario, then you can apply L'Hopital's rule. So L'Hopital's rule works when you have 0 over 0. We will deal with the case where we have infinity over infinity, but that's for another time. Let's keep it simple for the time being. So whenever you encounter a 0 over 0 scenario, then you can apply this. Well, applying this is here you've got one function, and here you've got another function. So just like up here, you've got one function here over another function. So if you're trying to evaluate one function over another function, with L'Hopital's rules, that you can differentiate the top function, and then differentiate the bottom function. That will then give you this, and then evaluate the limit of this. So, for example, with this one here, it's important that you check that it's 0 over 0. So here we've got a scenario where we've got, well, if you put this into here, put this into here, put this into here, you're going to get a 0 over 0. It's important that you check it's 0 over 0. In this case, it is. So now we can apply L'Hopital's rule. So differentiate the first function. That will then give you this. Because if you differentiate 3x, it will give you 3. Differentiate this, it will give you cos, and differentiate this, it will give you 1. So now rather than evaluating this, we would evaluate this. So evaluating this, we'll put this into here. That would be 3 take away. Well, if you put this into here, it will be cos of 0 will be 1, and then this is a constant, so it becomes 2 over 1. So the limit here is actually 2. Okay, so another example. Let's try and evaluate the limit of this. So the first thing we have to do is check that it's 0 over 0, because L'Hopital's rule only works if you have 0 over 0 and some other cases, but we will leave that for another time. But here we are now trying to evaluate this. So let's put 0 into here. 0, put this into here. Sine of 0 will be 0. Put this into here. You're going to get 0. So here we have got a case where it's 0 over 0. Then we can apply L'Hopital's rule. So L'Hopital's rule is that we can differentiate this. That will then give us this. And then this bottom function here, differentiate that will then give you this. So now let's try and plug it in. So this would be 1 minus, put 0 into here, it will be cos of 0 will be 1 over, put 0 into here, that will be 0. So here we've got 0 over 0. So here we can't really determine the limit yet. But we have got a scenario where it's 0 over 0. So we can apply L'Hopital's rule again. So applying L'Hopital's rule again, so differentiate the top function, that will then give you this. And then differentiate the bottom function, that will then give you this. So now let's try and evaluate this now. Put 0 into here. That will be sine of 0 will be 0. Put 0 into here. It will be 0 over 0. We can't evaluate the limit itself, but we have got a case where it's 0 over 0. So we can apply L'Hopital's rule again. So here, differentiate this function. That will then give you this. And then differentiate this. That will then give you this. So now plug this into here. So cos of 0 will be 1. This is a constant. So the limit here is actually 1 over 6, because nothing breaks down. Up here you've got 0 over 0. So you've got a number divided by 0. You can't divide anything by 0. It breaks down. But down here nothing breaks down. 6 here is a constant, is a legitimate answer. 1 divided by 6 is a legitimate answer. Here you've got a number divided by 0. You can't divide anything by 0. You just got to come to a stop. But here you've got a constant, so it is a legitimate answer. So the answer here is 1 over 6. Okay, so be careful, because Here's an example. You've got to be careful here. So here, applying L'Hopital's rule, you would differentiate this. That will then give you this. Differentiate this. That will then give you this. And then most people, they would just carry on differentiating it. Differentiate this, and then differentiate this, and then they would put 0 into here. So sine of 0 is 0. And then this is a constant. So they will conclude that it's 0, but it's actually wrong, because if you got to make sure that you've got a case where it's 0 over 0, and then you can apply L'Hopital's rule. So let's try and do this again. So put 0 into here. So you've got sine of 0, which will be 0. Put 0 into here. Then you've got 0 here. So here you've got 0 over 0. That's good. You can apply L'Hopital's rule. So differentiate this. That will then give you this. Differentiate this, and then that will give you this. But here's where it breaks down, because now if you put 0 into here, you're going to get cos of 0 will be 1, and then put this into here, you're going to get 0. So here you can't apply L'Hopital's rule. You can't continue. You just got to come to a stop. Here it breaks down. So the moral of the story here is that you've got to make sure it's 0 over 0, and then you can apply L'Hopital's rule. Okay? I will give you some examples in the next video. Okay?